So example, if in a question, if the mass was not given, then how you can work out the mass? In that case, you will use a periodic table. On your screen, you can see a periodic table, and this is the actual periodic table which you will find in the exam as well. So if I say I have two gases, say methane, which is CH4, and sulfur dioxide, that is SO2. And the question is, identify which gas the particles will move faster. So at a specific temperature or at a given temperature. So in this case, the masses for each element is not given, then how you can work out the mass? So when you check the periodic table, methane contain carbon and hydrogen. Here you can see a carbon. So this is a carbon, and what is the mass number? The higher number is the mass number. So what is the mass number of the carbon? The carbon mass number is 12. And what about hydrogen? You can see hydrogen here. So what is the, for hydrogen, its atomic number and atomic mass is same. So this lower number is representing the mass number. So in CH4, there is one carbon, so it is 12, 1 multiplied by 12, plus hydrogen mass is 1, and how many are there? How many hydrogen atoms are there? 4. So this will be 4. So 12 plus 4, that will make the total sum 16. When you check sulfur dioxide, so when you check the periodic table, the sulfur, you can find a sulfur here. So what is the mass of the sulfur? The mass of the sulfur is 32. And there is one sulfur, so it will be 1 multiplied by 32. Plus the mass of oxygen. What is the mass of oxygen? You can see oxygen here. And what is the mass of oxygen? It is 16. So it will be 16 multiplied by 2. So 32 multiplied by 1, that's 32, and 16 multiplied by 2, that's also 32. So 32 plus 32, that will make total sum 64. So which gas will diffuse, which gas the particle will move faster at a given temperature? Methane or sulfur dioxide? So as the methane is a lighter one, so methane at a particular temperature, the particle will move faster, and because it is a heavy, so the particle will move slower. Another example, but this time I want every one of you to solve this example. I will give you the name of the gases, and you have to identify which gas will diffuse faster and slower. You can use the chat to state the answer. Don't bother about right or wrong answer, but your participation is important, that everyone should participate. Example, we have ethane. Ethane is C2H6. And you have chlorine, which is Cl2. The question is, identify which gas the particle will move faster. Or which gas is particles are lighter. The periodic table is there on your screen. You can find carbon, The carbon is there, hydrogen is there, and chlorine. This is chlorine. So which gas the particles are moving faster? Yeah, what about others? Don't bother about the right or the wrong answer. That's not an issue because you are learning. So some answers, sometimes your answer will be right, sometimes it will be wrong. But the important thing is your participation, that you participate and give the answer. So when we work out in which gas the particles are moving faster, so we should work out the mass of each gas. So first, when we work out ethane, when you check ethane, carbon is 12, multiplied, how many carbon are there? 2. Plus hydrogen is 1, multiplied by how many are there? 6. So 12 multiplied by 2 is 24, and 24 plus 6, that is equals to 30. So this is 30. What about chlorine? Each chlorine is 35.5. And how many chlorine are there? 2. So 35.5 multiplied by 2, that will make the total sum 71. So it means ethane is lighter and chlorine is heavy. So ethane, it will move faster and chlorine molecules will move slower. Is it clear? Then another example, to work out the movement or the motion of the particles. You have, say, two gases, butane and chloromethane. The formula for butane, I want everyone to participate. Formula for butane is C4H10, and formula for chloromethane, it is CH3Cl. Again, the same question, you have to identify in which gas the particle will move faster or which gas is lighter. Because the lighter gases, the lighter particles will move faster. Butane is C4H10 and chloromethane is CH3Cl. So we have carbon, we have hydrogen, and we have fluorine. These are the three elements which are present in these two compounds. Take your time and work out the answer. So the mass of a butane, when we work out the mass, carbon is 12, because you can see here the mass of the carbon is 12, multiplied by how many are there? 4. So 12 multiplied by 4, that's 48. And that is 1 multiplied by 35.5. So it is, sorry, 1 multiplied by 10, not 35.5. I was checking chlorine there. So the total is 58, and here carbon is 12, plus hydrogen is 1 multiplied by 3, plus chlorine is 35.5. Not multiplied by 2 because only one chlorine is there. So this will be 15 plus 35.5. That's equal to 50.5. So which gas is lighter here? Butane, 12 multiplied by 4 plus 1 into 10, that's 58. And chloromethane, CH3Cl, 12 plus 3 plus, so chloromethane is lighter, so it will move faster. That's why I asked the other student as well, what about their answer? Is it clear the concept how to work out the masses of the gas from their atomic mass, the total mass of a gas, and working out that which gas will move faster? Then we have a heating curve. This is called a heating curve. Heating curve shows a relation between the temperature and time, and this graph shows a change in the state, how the one state of a matter changes to another state. So example, you have a solid initially, and you're heating a solid. So when you're supplying heat energy to a solid, and this change, you're plotting a graph for this change. It can be time on x-axis and temperature on y-axis. So you have a solid and you're supplying heat energy to this solid. So first what will happen in a solid, when the particles are tightly packed together, and when you're supplying the heat energy, so the energy will cause the particles to move at a high speed, or particles will move faster. So it will increase the speed of the particle, and when the speed of the particle changes, the temperature will change. So in the beginning, there will be a change in temperature. Like if there were numbers, if I say, so this was say 10, 20. So when you are supplying heat energy to a solid, the particles will gain energy, and when these particles will gain energy, they will move faster. So the temperature of a solid increases. Then what will happen at a certain temperature? What you will find, you will see at a certain temperature, the solid is changing the state, and that solid is turning into a liquid. So when the solid is turning into liquid, or a solid is changing into liquid, what is happening to the particles? Here the solid turn into liquid, and when this solid turn into liquid, the energy which you are supplying now, because you're supplying a heat energy to change the state. So the heat energy or energy which you're supplying is used to break the attraction between the molecules. So when the heat energy is used to break the attraction between the molecule, that time the speed of the molecule does not change. And when the speed of the molecule is not changing, so the temperature will remain same. So when the temperature remains same, what does it shows? It shows that there is a change in the state. So first, when you are supplying heat energy to a solid, the particles will move faster, the speed of the particle changes, but it does not affect the number of the particle. The number of the particle in a solid will remain same. It does not change. But only thing what happen is particle will move faster. But at a certain temperature, the particle now, their energy is used to break the attraction between the particle. And when energy is used to break the attraction between the particle, the solid will now start to change the state and it will turn into liquid. So in the beginning, you was having a solid. At this point, what we have when this changes, the state is changing, we will have both solid and liquid. But once all of the solid converted into liquid and you are further supplying energy, that time the temperature of the liquid will start or rise. And once it reaches a certain temperature and further supply in energy, when you further supply the energy, the particle will escape from the liquid, the particles will go out from the liquid, and it will be in a state of the boiling or evaporation. Basically, it's a boiling. So it will start to change its state and it will turn into a gas. So here you will have liquid and gas both. So simply what is happening whenever there is a, what you can work out, whenever the temperature is not changing, what does it mean? It means the state of a substance is changing. So when a solid is changing into liquid, we call melting. When a liquid is changing into gas, we call that as boiling or evaporation. And when you further supply energy to a gas, the temperature of the gas will increase, the particle will move faster. So the region where the temperature is constant or the temperature is not changing, it means there is a change in state in that region. If a temperature is constant, it means either a solid is changing into liquid or a liquid is changing into gas. Is it clear? This heating curve. So I'll repeat. First, we have a solid. We are supplying heat energy to a solid. The particle will move faster. At a certain temperature, the particle, instead of moving faster, they move away from each other. That state, that temperature, the state will change into liquid. When you further supply energy, the temperature of the liquid will rise, and at a certain temperature, the liquid will convert into gas, and we call that as boiling. So from the graph, how we can work out the melting point or the boiling point? If a question is state the melting point or a boiling point. So when a solid is converting into liquid, this region, a solid is converting into liquid. So you will draw a horizontal line on the temperature axis, and that temperature will be a melting point or a freezing point. And when a liquid is turning into gas, you will draw a horizontal line on a temperature axis, that will be the boiling point. So from this graph, you should be able to work out the boiling point or the melting point of a substance. Another example, if you have a graph, a heating curve, and you have to label the positions, the states. This is a graph. So we have position A, position B, C, D, and E. On y-axis, we have temperature. On x-axis, we have time. And the numbers are also there. Example, say this was 200, 400, 600, 800, 1000, and so on, degree centigrade. And the time is in minutes, 10, 20, and 30. Now the question is, identify the states or at A. What we will have, which state we will have at point A? Solid, liquid, gas, or solid liquid, or a liquid gas? At A, we'll have a solid. What about B? It will have both liquid and gas, or solid and liquid, sorry. Yeah, it is in a state of a melting and we'll have both states, solid and liquid. What about C? Which state we will have at C? A liquid. What about D? Liquid and gas. And what about E? We'll have only gas. Now, from this graph, what is the melting or the freezing point? Because melting and freezing point is the same thing. Only difference is the change in the state, like solid to liquid or liquid to solid. So what is the melting or the freezing point? Or temperature? Yeah, not from A to B, I mean specific temperature. What is the melting or the freezing point? Or the temperature at which this substance melt or freeze? So that is 400 degrees centigrade. And what about the boiling point? So boiling point is 800 degrees centigrade. So from the graph, whenever they ask a boiling point or a freezing point, you will just draw a horizontal line on y-axis to work out the boiling temperature or the melting temperature according to the state. Then working out the state of a substance at different temperature, how we can work out the state of a substance at different temperature. So there is a simple rule here. When we have a melting point and a boiling point of a substance, state of a substance before its melting point, any substance, uh, the state before its melting point, it is solid. State of a substance between its melting and the boiling point, it will be a liquid. And state of the substance after the boiling point, it will be a gas. So a substance before its melting point, it is solid. A substance between the temperature of a substance at a particular temperature, if the temperature is between its melting and a boiling point, the substance will be liquid. And if it is after the boiling point, the substance will be a gas. Example, if I say I have 4 different substances and I want to find the states. Melting point, in short, I'm writing MP. Boiling point, in short, I'm writing BP. And the third one is the state. So we have, say, 4 samples, A, B, C, and D. And the melting point of sample, the first sample, that is -30, and the boiling point is 20. For substance B, the melting point is 0 and the boiling point is 100. For substance C, the melting point is 1500 and the boiling point is 2900. And for substance D, the melting point is 5 and the boiling point is 78. Now the question is, what is the state of the substance at 25 degrees centigrade? So we want to find the state of the substance at 25 degrees centigrade. So how we can work out the state at 25? So we have to first check where the 25 is coming for this range. Like a number line. You have -30 and 20. So where 25 will come? The number 25. After the boiling point, between the melting and boiling point, or before the melting point? For substance A, it will come out after the boiling point because 25 is more than 20. So 25 will be here. Because it is from -30, it's like a number line. In mathematics, you have a number line. Like example, it is -30 and 20. So where I will write 25. So 25, it will come out after 20. So means it will be on the right hand side of a boiling point. So when the temperature is higher than the boiling point or after the boiling point, so what will be the state of sample A if the temperature is more than the boiling point? Solid, liquid or gas? A substance might be solid, liquid or gas depending on the temperature. If the temperature is more than the boiling point, then it will be a gas. So substance A is actually a gas. So at 25, the substance A will be gas. Is it clear to everyone? Now we check for substance B. We are finding the state of substance B at 25. So where 25 will come for substance B? Before melting point, between melting and boiling point, or after the boiling point? Where the 25 degrees centigrade? So 25 will be between melting and boiling point, or before the boiling point, you can say 25. So if the temperature is between the melting and the boiling point, what will be the state of the substance? If the temperature between the melting and boiling point, what is the state of the substance at that 25 degrees centigrade? So that substance will be a liquid. If it is before the melting point, then it will be solid. You can see here, when the temperature is between the melting and the boiling point, the substance is liquid. If it is before the melting point, then the substance will be a solid. Same thing, if we check for sample C at 25, where the 25 will come? $25. It is 1,500 and 2,900. So 25, it will be before the melting point. So if it is before the melting point, what will be the state of the substance? So it will be a solid. And what about D, 5 and 78? Where 25 will come for sample D? So it will be between. If it is between, then what will be the state? It will be a liquid. So simply, if a substance, if a temperature at which you are finding the state, if that temperature is lower than the melting point, then it will be solid. If that temperature between the melting and boiling point, it will be liquid. And if it is after the boiling point, it will be a gas. Is it clear? Another example, we have this one is a 200, 700, 1,200, 4,800, minus 36, minus 20, and minus 8, 20. This is a melting point, boiling point, a sample. and state. Now my question is, what is the state at 30 degrees? Sample A, state at 30, solid, liquid or gas? So that's right, it will be a solid as you work out. So 30 will be here. It's before the melting point, so it will be solid. That's correct. What about B? What will be the state? B also solid because when you work out 30, it's before the melting, so it will be a solid. What about C? So minus 36 and minus 20. So where 30 will come, it will be a temperature after the boiling point. So if it is after the boiling point, it means it will be a gas. And what about D? The 30. That's also after the boiling point, so it will also be a gas. So first two samples are solid at room temperature, and the next two samples are gas at 30 degrees. Is it clear? Any question or a doubt related to the class? So we basically discuss the first topic. We did not complete yet. Still, will continue. We started with the basic paper selection 246, then the particulate nature, the properties of solid, liquid, and gas, the arrangement of the particles, the particle theory, the relation between temperature and the change in state, and how we can predict the state at certain temperature. So I'll end the session and share this recording with you.